Welcome back. In today's class, we are going to be talking about subtraction in number bases. Subtraction has to do with taking one number away from the other. You should recall that in our previous class, we discussed addition, and we mentioned that this operation has to be done digit by digit. Without further ado, let's begin. So let us look at this one. The question said that subtract this value from this. Subtract 2345 from 2908. That is how it is read, because it is read, so you can see subtract, which is subtract. This sign qualified this, so subtract 2345 from 2908. How do we do this? We go digit by digit from our right to our left. Now, in this case, they don't show us any base. The implication is that if there is no base, they are using base 10. So let us now begin to do the subtraction. Number 1, 8 minus 5, this is 3. Why? Remember the principle of that operation. It said that answer must less than the base. This is our answer. This is less than the base. So if we are going to write the answer, this value must less than the base value. The base value is 10. 0 minus 4, impossible. Because every digit in the bigger number must be greater than every digit in the lesser number. This number here, the sign is positive because this one is times sign, and if we don't show the sign of the previous number, that is also to be plus. So every digit in the higher number must be greater than every digit in the lower number. So for that reason, we take away 1 from this place and put it here. They call it borrow. So in that scenario, what do? When this 1 move from 9 to this place, are you getting me? We borrow only 1 from 9. That's make this 9 to remain 8. When this one get to this place, it automatically become 10. Why does it become 10? Because we are working in base 10. If we are working in base 3, it will become 3. If we are working in base 4, it will become 4. So now we are having 10 minus 4. This is 6. The next digit is 8. 8 minus 3, that is 5. So 2 minus 2, that is 0. So we are left with what? 563, which is correct answer. But in some scenario, they may ask you to do something like this. Please, this operation is not correct. You are not going to get any meaningful answer. Then let us prove it that it is true. Why are you not going to get any meaningful answer? You can say that here our bigger number is negative while our lesser number is positive. You are not going to get any answer concerning that. The bigger number have to be positive while the lesser number have to be negative for you to get the correct answer. Let us perform the operation here. Maybe we are going to get anything meaningful. Look at it. 5 minus 8. Impossible. So we borrow 1 from this one here and put it here. That is to say this one will become 15 because the 1 will become 10 and we add it to 5. It becomes 15. 15 minus 8, that is 7. You can see that is 7. It's not even giving us anything that has to do with this or its negative form. Are you getting me now? That's the reason why it's not possible. So before you perform that operation, that principle must be there. So let us go to the next one. The next one is operation in base 2. Are you getting me? Let us see how we are going to do this. 8 minus 5, that is 3. The question is, can we write that 3? No, because that 3 is bigger than the base. So we are going to subtract the base from it until it is less than the base. Are you getting me now? So what are we going to do in this scenario? take away 2, are you getting me? Take away 2 from 3, we are going to get 1. Okay, so the next question is, how many times do you take away 2? We take 2 away, just one time. That one time that you take 2 away, they say that you keep 1. That one that you keep, before performing any operation at all, you have to add it to the next digit here. So this one will become 1 automatically. Once this one becomes 1, you cannot begin to perform your operation. 1 minus 4, impossible, because this digit cannot less than this for that operation to be done. What do? We borrow 1 from this place. The one that we borrow from this place, remember, its value is 2 because we are working in base 2. Okay, so that 2 we add it to the one that is here, that make it 3. Can we still perform a subtraction? No. We still need another one here. We borrow another one here and put it here again. So we borrow 1 twice, and each one is 2. 2 times 2, 4, plus 1, 5. Now, that 5 minus 4, that make it 1 without any subtraction issue. What is next? We have removed 2 from this 9. That makes it to remain 7. Minus 3. This is 4. Can we write the 4? No. We are going to subtract 2 times from 4. That is to say, we are keeping what? We are keeping 2. That 2 that we keep, immediately add it to the next digit here. 2 plus 2, that is 4. Minus 2, that is 2. Can we write the 2? No. Subtract 2, we are left with 0. How many times do we subtract 2? Only once, that is, we kept 1. So there is no any other digit again. So this one will be added to the next piece here, although it is empty. So that we bring it down here because it is less than 2. So this is what we call 10,011. This is how it is done. But you cannot do anything like this one. Are you getting me? You know the reason why. You can see that this number here, which is bigger, is negative, while this one is positive. So you cannot do anything like this for this one. Are you getting me? So let's go to the next number. The next number is in base 3. Are you getting me? So let us try to do it and get our answer. Let us see. 5 minus 8. Impossible. We borrow 1 from this place. That one that we borrow, what value it is? It is 3. We add it to this 5, making 8. So 8 minus 8, that is 0. So this one remains 3 minus 0, that is 30. That is 3. So here now, we are having 3. 3 minus 9, impossible. We remove 1 from this place, add it to this one. It becomes 6. Because that one that we borrow becomes 3 here. 3 plus 3, that is 6. Minus 9. We can't still do it. We have to borrow another one. So now it has become 9. 9 minus 9, that is 0. And that this 4 now it has become 2. 2 minus 2, that is 0. So answer is what? 30. 30. So now I want you to follow steps when you are doing your work, because mathematics is concept of steps. Don't do mistake to meet the steps. They are very, very important. Remember the basic principles. Remember the steps. Surely your answer will surely come out. For you to excel in your academic excellence, in your academic career, you have to spend time. You have to spend money. You are spending money in terms of your MB that you are using to watch this, and you are spending time by looking at it as well. I want you to pay attention and focus so that it can contribute more positively to your life. Thank you for watching. We appreciate your subscription. We appreciate your follow. This gives us more blow to do more. It encourages us to do more so that you and I can benefit and learn more from mathematics. You can try this by yourself at your own time to see what is your answer as well as this. But remember, when we have number that is more than base 9, anything from 10, we represent them with alphabet. Are you getting me? If you have something like base 17, base 18, base 19, base 20, we use alphabet until we consume our Z from A to Z. This is how logic behind number subtraction in number basis is working. In the next class, we are going to be looking at multiplication followed by this division followed by number based conversion. Thank you for listening. ABP.